On the morning of November 7, 1942, a crate arrived at the Heereswaffenamt testing facility in Kummersdorf, approximately 50 kilometers south of Berlin. Inside, packed in straw and oiled paper, was a rifle that German ordnance engineers had been waiting months to examine. An American M1 Garand semi-automatic rifle, serial number 410338, manufactured at Springfield Armory in Massachusetts sometime in early 1941. The rifle had been captured from American forces during Operation Torch, the Allied invasion of North Africa. It had been shipped from Tunisia to Italy, then by rail through the Alps to Germany. The Heereswaffenamt, the German Army Weapons Agency, had established testing protocols for captured enemy weapons since 1939. Every significant foreign weapon system that fell into German hands ended up at facilities like Kummersdorf or Hillersleben for systematic evaluation. The Germans tested everything: Soviet rifles, British, machine guns, French artillery pieces, American pistols. They wanted to understand what their enemies were using, how it worked, what advantages it might provide, what weaknesses could be exploited. But the M1 Garand represented something different. German intelligence reports from North Africa in late 1942 had described American infantry units equipped with semi-automatic rifles as standard issue. Not just specialized troops or elite units. Every American rifleman carried a semi-automatic weapon. This was unprecedented. No other army in the world had achieved that level of modernization for its standard infantry forces. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German army, the Wehrmacht, equipped its infantry with the Kar98k, universally known as the Kar98k. It was a bolt-action rifle, a direct descendant of the Gewehr 98 designed by Paul Mauser in 1898. 44 years of refinement had made the Kar98k reliable, accurate, and simple to manufacture. German industry could produce Kar98k rifles by the hundreds of thousands. The rifle was 5-shot capacity, fed from a stripper clip loaded from the top. A trained German soldier could fire approximately 15 aimed shots per minute under ideal conditions. 10 shots per minute was more realistic in combat stress. The Kar98k weighed approximately 4 kilograms unloaded. It was 1.11 meters long. It fired the 7.92 by 57 mm Mauser cartridge, a powerful round with excellent range and stopping power. The rifle had been tested extensively. It functioned in mud, snow, desert sand, Arctic cold, tropical heat. It rarely jammed. It could be field stripped and reassembled by a soldier with minimal training. Replacement parts were standardized and available throughout the Wehrmacht supply system. From a logistics perspective, the Kar98k was nearly perfect. But it was slow. Each shot required manual operation of the bolt. Open the bolt, extract the spent cartridge, close the bolt to chamber a new round, aim, fire. 5 shots, then reload with a stripper clip. The process was mechanical, reliable, and time-consuming. A rifleman armed with a Kar98k could control his sector of a battlefield effectively at range. But if an enemy closed the distance rapidly, or if multiple targets appeared simultaneously, the bolt-action design became a limitation. German military doctrine had evolved around this limitation. Infantry tactics emphasized coordinated fire, with machine guns providing suppressive fire, while riflemen delivered aimed shots. The MG-34, and later the MG-42 machine guns, were the primary sources of firepower in German infantry squads. Riflemen supported the machine guns, protected them, provided security. The squad automatic weapon, not the individual rifle, determined the squad's combat effectiveness. But American doctrine was different. Intelligence reports suggested that American infantry squads relied heavily on individual riflemen equipped with semi-automatic weapons. The M1 Garand allowed American soldiers to maintain aimed fire without manual bolt operation between shots. Theoretically, this provided American infantry with significantly higher rates of fire compared to bolt-action equipped forces. The question German ordnance engineers needed to answer was simple and urgent. Was the M1 Garand actually effective in combat conditions, or was it an overcomplex weapon that would fail under field stress? The evaluation team at Kummersdorf included engineers from the Heereswaffenamt's Small Arms Division, ballistics specialists, and experienced Wehrmacht armourers who understood what infantry weapons needed to survive combat. The team leader was Oberingenieur Klaus Richter, a 43-year-old mechanical engineer who had worked in German small arms development since the mid-1930s. Richter had evaluated dozens of captured weapons during the war. He approached each evaluation with the same systematic methodology: document the design, test its function, measure its performance, identify its weaknesses. The M1 Garand was unpacked carefully on November 9th. The rifle was in excellent condition. The stock showed minor wear but no damage. The metal components had a dark, parkerized finish that resisted corrosion. The barrel was clean, showing minimal wear from firing. The rifle's weight was immediately apparent. At approximately 4.3 kilograms unloaded, it was slightly heavier than the Kar98k. But the weight was distributed differently. The Garand felt balanced, almost muzzle-light compared to the Kar98k's forward-heavy balance. Richter and his team began by field-stripping the rifle to examine its internal mechanisms. The M1 Garand used a gas-operated, rotating bolt system. When a round was fired, some of the propellant gas was diverted through a port in the barrel into a gas cylinder located beneath the barrel. This gas pressure drove an operating rod rearward. The operating rod was connected to the bolt through a rotating cam. As the rod moved back, it rotated and unlocked the bolt, extracted the spent cartridge, and cocked the hammer. A return spring drove the operating rod forward again, stripping a new round from the magazine and chambering it, then rotating the bolt to lock it closed. The entire cycle happened automatically in a fraction of a second. The German engineers recognized immediately that this was sophisticated engineering. The tolerances were tight, the components were machined precisely. The gas system required exact alignment between the gas port in the barrel and the gas cylinder beneath. The operating rod had to slide smoothly in its channel without binding. The bolt lugs had to engage correctly with the receiver. Any misalignment, any excess fouling, any damaged component could cause the system to malfunction. This was exactly the type of complexity German engineers had learned to avoid. Combat weapons needed to function with minimal maintenance, needed to tolerate dirt and moisture, needed to work even when worn or slightly damaged. The Kar98k achieved this through mechanical simplicity. The bolt was operated manually by the soldier. If something went wrong, the soldier could feel it immediately and correct it. The M1 Garand relied on precise gas pressure and tightly toleranced moving parts. If something went wrong, the rifle might simply stop functioning until an armourer could repair it. The magazine system was particularly unusual. The M1 Garand used an 8-round en-bloc clip. The clip was a thin piece of stamped steel that held 8 cartridges in a single row. To load the rifle, the soldier pulled back the operating rod handle to open the action, inserted the entire clip into the receiver from the top, and released the operating rod. The bolt stripped the first round from the clip and chambered it. After the 8th round was fired, the empty clip was automatically ejected from the rifle with a distinctive metallic ping sound. The ejection of the clip opened the action, signaling the rifle was empty and ready to be reloaded. German engineers noted this immediately as a potential tactical disadvantage. The audible ejection of the empty clip could signal to enemy forces that an American soldier was reloading. A perceptive enemy could time an assault for the moment when multiple American riflemen were reloading simultaneously. Additionally, the en-bloc clip system meant soldiers could not easily top off their rifles by adding individual rounds. If a soldier had fired 3 rounds and wanted to reload, he would have to eject the partially full clip, wasting 5 good cartridges, or continue with only 5 rounds remaining. The Kar98k allowed soldiers to load individual rounds into the internal magazine at any time, maintaining maximum ammunition capacity. But these were theoretical concerns based on mechanical examination. The critical question was performance. How did the M1 Garand actually function under firing conditions compared to the Kar98k? The first firing tests took place on November 12, 1942, at the Kummersdorf small arms range. The temperature was 3 degrees Celsius, overcast, light wind from the northwest, standard autumn weather for northern Germany. The test protocol was straightforward. Fire the M1 Garand and compare its performance directly against the Kar98k in multiple categories, including rate of fire, accuracy, reliability, and ease of use. The ammunition for the M1 Garand was American-made .30-06 Springfield cartridges, captured along with the rifle. The .30-06, formerly designated as the 7.62 by 63 mm cartridge, was similar in performance to the German 7.92 by 57 mm Mauser round. Both were full power. Rifle cartridges designed for long-range effectiveness. Ballistic performance would be roughly comparable. 2 test shooters were selected. Both were experienced Wehrmacht soldiers. Both had extensive rifle training. Both understood proper marksmanship fundamentals. Neither had fired an M1 Garand before this evaluation. They received brief instruction on loading, operating the safety, and basic function. No extensive training, just enough to operate the weapon safely. The first test measured maximum rate of fire. How quickly could a shooter engage targets with aimed fire? The test shooter took position at the 50-meter line with the M1 Garand. 8 targets, simple silhouettes painted on boards, arranged in a line across the range. The scenario was simple. Engage all 8 targets as quickly as possible with aimed fire. The timer started. The shooter shouldered the rifle, acquired the first target, pressed the trigger. The rifle fired with a sharp crack. The recoil was moderate, similar to the Kar98k. The rifle cycled automatically, no need to work a bolt. The shooter shifted aim slightly to the second target, fired again. Third target, fourth target, fifth, sixth, seventh, eighth. All 8 shots in rapid succession. The rifle fired smoothly, consistently. The gas system cycled reliably. The empty clip ejected with its characteristic ping. The elapsed time was recorded, 4.3 seconds for 8 aimed shots at 50 meters. The test was repeated with the Kar98k for comparison. Same shooter, same targets, same distance. The shooter loaded 5 rounds into the Kar98k's internal magazine, took position, started the drill. First shot. Operate the bolt, lifting the handle, pulling back, pushing forward, rotating down to lock. Acquire second target. Fire. Operate the bolt again. Third target. Fire. Bolt. Fourth target. Fire. Bolt. Fifth target. Fire. The magazine was empty. The shooter loaded a second stripper clip. 2 more shots to engage the remaining targets. Elapsed time. 12.1 seconds for 8 shots. The difference was dramatic. The M1 Garand had delivered 8 aimed shots in less than half the time required by the Kar98k. The semi-automatic action eliminated the manual bolt operation between shots. The shooter could maintain sight picture, maintain target focus, simply press the trigger repeatedly without breaking his cheek weld or losing his aim point. The test was repeated multiple times with both rifles to ensure consistency. The results were consistent. The M1 Garand consistently achieved approximately 2.5 to 3 times the rate of fire compared to the Kar98k in realistic aimed fire scenarios. Richter and his team documented these results carefully. The implications were significant. In a direct firefight between forces equipped with M1 Garands and forces equipped with Kar98ks, the side with semi-automatic rifles could deliver substantially more fire in the same time period. More rounds on target meant higher probability of hits, meant greater suppressive effect, meant tactical advantage. But rate of fire was only one metric. Accuracy mattered, reliability mattered, durability mattered. The accuracy tests measured group size at various distances. Both rifles were fired from bench rest positions to eliminate shooter error as much as possible. At 100 meters, both the M1 Garand and the Kar98k produced groups measuring approximately 8 to 10 centimeters, roughly 3 to 4 inches. At 200 meters, groups opened to 15 to 20 centimeters. The rifles were comparable in mechanical accuracy. Neither had a significant advantage. The reliability tests were more revealing. The M1 Garand was fired extensively over several days, 300 rounds, then 500 rounds, then a full 1,000 rounds with only minimal cleaning between firing sessions. The German engineers wanted to see how the gas system would function as fouling accumulated in the gas, cylinder, and operating rod channel. The rifle functioned reliably through the first 300 rounds. No malfunctions, no failures to feed, no failures to eject. The action cycled smoothly. At around 400 rounds, with significant carbon fouling building up in the gas system, the rifle began to show signs of stress. The operating rod was moving slightly slower. The bolt was not closing completely on some rounds, requiring the shooter to manually push the operating rod forward to ensure full lockup. By 600 rounds without cleaning, malfunctions became more frequent. Failure to fully cycle, failure to lock the bolt, occasional failure to eject the empty clip. The German engineers cleaned the rifle, focusing particularly on the gas cylinder and operating rod channel. After cleaning, the rifle returned to reliable function immediately. The lesson was clear. The M1 Garand required regular maintenance to function reliably. The gas system, while effective, accumulated, fouling that degraded performance. This was not unexpected. Any gas-operated weapon required cleaning to maintain function, but it represented a maintenance requirement that the Kar98k did not have. A bolt-action rifle could continue functioning even when extremely dirty because the soldier manually provided the force to operate the action. Durability testing involved harsh treatment. The rifles were deliberately exposed to mud, sand, water, and cold. Both the M1 Garand and the Kar98k were submerged in water, then fired immediately. Both functioned. Both were dropped from standing height onto concrete. Both survived without damage affecting function. Both were exposed to mud, coating the action with thick, clay-like soil, then fired. The Kar98k continued functioning with manual effort to work the bolt through the mud. The M1 Garand initially failed to cycle automatically, but once the shooter manually cycled the action once to clear the initial fouling, it resumed automatic operation. Neither rifle was perfect, but both proved reasonably durable under abuse. The evaluation continued through late November and into early December of 1942. Additional M1 Garands arrived at Kummersdorf, as more were captured in North Africa. The testing expanded. Different shooters, different scenarios, different conditions. The results remained consistent. The M1 Garand provided approximately 2.5 times the practical rate of fire compared to the Kar98k. It was accurate. It was reasonably reliable if properly maintained. It was well manufactured with good quality control. On December 18, 1942, Oberingenieur Richter compiled the final evaluation report. The document was typed on official Heereswaffenamt letterhead, classified as restricted distribution, and sent to Wehrmacht High Command for review. The report's conclusions were straightforward and based entirely on measured performance data. The M1 Garand represented a significant advance in infantry rifle design. Its semi-automatic operation provided tactical advantages in rate of fire. American infantry equipped with M1 Garands could deliver substantially more fire than German infantry equipped with Kar98k rifles in direct engagements. The rifle was well engineered and well manufactured. Its complexity required more maintenance than bolt-action rifles, but this maintenance was manageable with proper training. The report included a specific comparison that would become significant in German military planning. In the time required for a soldier with a Kar98k to fire 10 aimed shots, including reloading time, a soldier with an M1 Garand could fire approximately 40 aimed shots. This comparison was not theoretical. It was based on timed firing tests with experienced shooters using both rifles under identical conditions. The ratio varied slightly depending on distance and target type, but the general pattern was consistent. The semi-automatic rifle provided approximately a 4-to-1 advantage in practical rate of fire. Richter's report did not recommend immediately replacing the Kar98k with a semi-automatic design. The report was technical evaluation, not strategic recommendation, but the implications were obvious to anyone reading the document. Germany was equipping its infantry with a rifle design that was fundamentally outmatched by American standard-issue weapons. The report was distributed to relevant offices within the Wehrmacht command structure. Copies went to infantry training commands, to logistics planning offices, to the small arms development section at the Heereswaffenamt. The document was read, filed, and largely set aside. Germany had bigger concerns in December of 1942 than upgrading infantry rifles. The irony of the Kummersdorf evaluation was that German ordnance engineers already knew everything the tests confirmed. Germany had been developing semi-automatic rifles for decades. The Wehrmacht understood the tactical value of self-loading infantry weapons. What the M1 Garand evaluation revealed was not that semi-automatic rifles were superior, but that the Americans had actually succeeded in mass-producing and fielding them as standard equipment, while Germany had not. German semi-automatic rifle development dated back to the 1920s. The Weimar Republic, operating under the restrictions of the Treaty of Versailles, had limited options for military development, but civilian firearms manufacturers continued research and development. Mauser, the company that had created the Gewehr 98, experimented with self-loading rifle designs throughout the 1920s and early 1930s. By 1941, Germany had 2 semi-automatic rifles in limited production. The Gewehr 41, known as the G41, existed in 2 variants: the G41M, manufactured by Mauser, and the G41 Double, manufactured by Walther. Both rifles were gas-operated semi-automatic designs chambered for the standard 7.92 by 57 mm Mauser cartridge. Both were intended to supplement and eventually replace the Kar98k as the standard German infantry rifle. The G41M used a unique gas system designed by Mauser engineers. Rather than tapping gas from the barrel through a port, the Mauser system used a muzzle trap. Gas pressure at the muzzle was captured and redirected backward to operate the action. This system avoided drilling a hole in the barrel, which Mauser engineers believed would maintain better accuracy. The rifle weighed approximately 5 kilograms, held 10 rounds in a fixed magazine loaded with stripper clips, and had an effective range comparable to the Kar98k. The G41W, the Walther variant, used a similar muzzle trap gas system, but with different mechanical implementation. Walther's design was slightly simpler mechanically, though still complex compared to traditional bolt-action rifles. The rifle also weighed approximately 5 kilograms and used the same 10-round fixed magazine system. Both rifles entered limited production in 1941. Both were issued to Wehrmacht units on the Eastern Front for field evaluation. Both proved to be disasters. The muzzle trap gas system, which both designs used, was fundamentally flawed for military use. The gas trap mechanism was located at the very end of the barrel, exposed to everything the rifle encountered: mud, snow, dust, debris, anything that accumulated on the muzzle could interfere with the gas trap's function. The system required precise alignment and clean surfaces to operate correctly. In combat conditions, precise alignment and clean surfaces were impossible to maintain. German soldiers issued G41 rifles reported constant malfunctions. The rifles would fire a few shots, then fail to cycle. The gas system would become fouled or misaligned, and the rifle would revert to manual operation, requiring the soldier to manually pull back the operating handle after each shot. At that point, the soldier essentially had a heavy, awkward bolt-action rifle that weighed a kilogram more than the Kar98k and was slower to operate manually. Field reports from the Eastern Front in late 1941 and early 1942 were uniformly negative. Units equipped with G41 rifles requested their Kar98k rifles back. Armourers complained that the G41 required constant maintenance and adjustment, that could not be performed in field conditions. The rifles were too complex, too sensitive to environmental conditions, too unreliable for combat use. By mid-1942, production of both G41 variants was scaled back dramatically. The few thousand rifles that had been manufactured remained in service, but no large-scale production was authorized. The Wehrmacht's semi-automatic rifle program had failed. Then, in 1943, Walther engineers developed an improved design. The Gewehr 43, the G43, abandoned the problematic muzzle trap system entirely. Instead, Walther adopted a conventional gas port system similar to the Soviet SVT 40 rifle, which German forces had captured in large numbers on the Eastern Front. The gas port was drilled partway down the barrel. Gas was tapped off and directed into a gas cylinder above the barrel. The gas drove a piston that operated the bolt. This system was simpler, more reliable, and less sensitive to environmental conditions than the muzzle trap design. The G43 weighed approximately 4.4 kilograms, slightly heavier than the Kar98k, but lighter than the earlier G41 rifles. It used a 10-round detachable box magazine that could be loaded with individual rounds or stripper clips. The rifle included mounting rails for a telescopic sight, making it suitable for designated marksman roles. The G43 entered production in late 1943. Walther manufactured the rifles at their Zeller-Mehlis facility. Production ramped up through 1944. Approximately 400,000 G43 rifles were manufactured between 1943 and 1945. 400,000 rifles sounds like substantial production, but Germany was fielding millions of soldiers. The Wehrmacht, the Waffen-SS, the Luftwaffe field divisions, the Kriegsmarine coastal defense units, the Volkssturm militia formations organized in late 1944, all required rifles. Even at peak production, Germany was manufacturing approximately 20 times as many Kar98k rifles as G43 rifles. The G43 was never intended as a universal replacement for the Kar98k. Production capacity did not exist. Industrial resources did not exist. The strategic situation in 1943 and 1944 did not allow for complete retooling of rifle production. Instead, the G43 was issued selectively to specific units and specific roles. Infantry squads might receive 1 or 2 G43 rifles for designated marksmen. Fallschirmjäger units, German paratroopers, received G43 rifles in higher proportions. Waffen-SS divisions received priority allocation. But the average Wehrmacht infantryman continued carrying a Kar98k through the end of the war. The reasons for this limited adoption were practical and industrial, not technical. By the time the G43 had been developed into a reliable weapon, Germany's industrial situation had deteriorated severely. Allied bombing campaigns were disrupting production. Raw materials were increasingly scarce. Skilled labor was being drafted into combat units faster than factories could train replacements. Manufacturing capacity that existed was prioritized for weapons that could be produced quickly in large numbers. The Kar98k could be manufactured efficiently. Mauser had been producing essentially the same rifle design since 1898. The tooling was mature. The processes were refined. Multiple manufacturers could produce Kar98k rifles and components. The rifles could be assembled from parts produced at different facilities. The supply chain was well established. A Kar98k required approximately 10 hours of skilled labor to manufacture. A G43 required approximately 30 hours of skilled labor, plus more complex machining operations, plus tighter quality control standards to ensure the gas system functioned correctly. From a logistics perspective, equipping the entire Wehrmacht with G43 rifles would have required tripling the man-hours invested in rifle production while significantly reducing the total number of rifles produced. The mathematics did not work. Germany needed rifles immediately and in massive quantities to replace combat losses and equip new formations. The Kar98k met that need. The G43 did not. But the decision to continue relying primarily on bolt-action rifles, while the Americans fielded semi-automatic rifles as standard equipment, created a tactical disadvantage that German infantry experienced directly in combat. American forces landed in Normandy on June 6, 1944. By that time, essentially every American rifleman in the invasion force carried an M1 Garand. The 1st Infantry Division, the Big Red One, which landed on Omaha Beach, was equipped entirely with M1 Garands for its riflemen. The 29th Infantry Division, landing alongside them, was similarly equipped. The 4th Infantry Division, landing on Utah Beach, the 82nd Airborne Division, and the 101st Airborne Division, dropping inland, all carried M1 Garands as their standard infantry rifle. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The German forces defending Normandy were equipped primarily with Kar98k rifles. The 352nd Infantry Division, defending Omaha Beach, carried Kar98k rifles as standard equipment. The 716th Static Infantry Division, defending the coastal areas around Caen, carried Kar98k rifles. The elite German units, including elements of the 21st Panzer Division and the 12th SS Panzer Division Hitlerjugend, had some G43 rifles distributed among their infantry, but the majority of their riflemen still carried Kar98k bolt-action rifles. The firepower differential became apparent immediately in close-quarters combat. American infantry advancing through the Norman hedgerows encountered German defensive positions at short ranges, often under 50 meters. At these ranges, marksmanship was less critical than volume of fire. The side that could put more rounds downrange faster had the advantage. American squads could deliver sustained semi-automatic fire from multiple riflemen simultaneously. German squads relied heavily on their MG-42 machine guns for sustained fire, with riflemen supporting. If the MG-42 was suppressed or knocked out, the squad's firepower dropped dramatically. American squads maintained significant firepower, even if their Browning automatic rifle, their squad automatic weapon, was lost because every rifleman still had a semi-automatic rifle. German after-action reports from Normandy documented this firepower disparity. A report from the 352nd Infantry Division, dated June 15, 1944, noted that American infantry small arms fire was substantially heavier than anticipated. The report specifically mentioned that American riflemen appeared to be equipped with automatic or semi-automatic weapons in large numbers, creating fire superiority in infantry engagements. A Wehrmacht tactical assessment from July 1944, analyzing the first month of fighting in Normandy, stated that American infantry squads demonstrated higher small arms firepower than German squads of equivalent size. The assessment attributed this to widespread use of semi-automatic rifles among American forces. The document recommended increasing distribution of G43 rifles to frontline units to partially offset this disadvantage, but acknowledged that production capacity made this recommendation difficult to implement. Individual German soldiers expressed the same observation in letters and diaries. A letter from a Wehrmacht Obergefreiter, a corporal, serving with the 243rd Infantry Division in Normandy, dated July 23, 1944, described fighting American infantry near Saint-Lô. The soldier wrote that American riflemen could fire as quickly as a German soldier could work his bolt. Multiple American riflemen firing together sounded like machine gun fire. The German soldier noted that his squad had to rely heavily on their MG-42 to match American rifle fire, and when their machine gun was destroyed by American artillery, the squad could not generate enough fire with their Kar98k rifles to effectively suppress advancing American infantry. These were not isolated observations. They appeared consistently in German reports from every sector of the Normandy front. The tactical pattern was clear. In infantry engagements, especially at close range in the hedgerows and bocage terrain, American infantry equipped with M1 Garands could deliver significantly more fire than German infantry equipped with Kar98k rifles. The firepower advantage extended beyond simple rate of fire. The M1 Garand allowed American soldiers to maintain suppressive fire while maneuvering. In small unit tactics, one element provides covering fire, while another element moves. With semi-automatic rifles, the covering element could deliver effective fire without the pauses inherent in operating a bolt-action rifle. This made American fire and maneuver tactics more effective. German doctrine had developed around the capabilities and limitations of bolt-action rifles. Fire and maneuver tactics were built around the machine gun as the primary fire element. Riflemen supported the machine gun, but were not expected to provide sustained covering fire themselves. American doctrine, developed with the assumption that every rifleman had a semi-automatic weapon, distributed suppressive fire capability more broadly across the squad. The result was that American infantry squads were more flexible tactically. They could split into smaller elements more easily because each element retained significant firepower. German infantry squads could not split as effectively because the MG-42 machine gun represented such a large percentage of the squad's total firepower. Separating from the machine gun meant operating with limited firepower capability. By August of 1944, as American forces broke out from Normandy and began the rapid advance across France, German military assessments of American equipment and tactics became increasingly focused on the M1 Garand's impact. A Wehrmacht intelligence summary from late August 1944 specifically analyzed American infantry weapons. The document noted that the M1 Garand provided American infantry with a significant tactical advantage in terms of sustained firepower. The document concluded that German infantry, equipped primarily with bolt-action rifles, were at a disadvantage in direct firefights with American forces unless German units could establish defensive positions that maximized the effectiveness of machine guns and crew-served weapons. This assessment was not defeatist propaganda or exaggeration. It was a straightforward tactical analysis based on combat experience. German soldiers who had fought American infantry recognized that American riflemen could shoot faster, reload faster, and maintain fire more consistently than German riflemen with bolt-action rifles. The Eastern Front provided additional evidence of the semi-automatic rifle's tactical value. Soviet forces began receiving large numbers of semi-automatic rifles in 1940 and 1941. The SVT-38 and the improved SVT-40, both designed by Fedor Tokarev, were gas-operated semi-automatic rifles chambered for the Soviet 7.62 by 54mm rimmed cartridge. Soviet industry produced approximately 1.6 million SVT rifles between 1938 and 1945. Like the Americans, the Soviets initially intended to equip all infantry with semi-automatic rifles. Unlike the Americans, the Soviets could not sustain this plan. The SVT rifles were complex to manufacture and required skilled labor. When Germany invaded the Soviet Union in June 1941, Soviet industrial capacity was disrupted severely. Factories were evacuated eastward. Production priorities shifted to weapons that could be manufactured quickly with minimal skilled labor. The Soviets adopted the PPSH-41 submachine gun for mass production instead. The PPSH-41 was simpler to manufacture than the SVT-40, required less machining, and provided high volumes of automatic fire at close range. Soviet infantry squads were equipped with multiple PPSH-41 submachine guns, providing devastating short-range firepower. The SVT-40 remained in production, but in much lower numbers, issued primarily to designated marksmen and more experienced soldiers. German forces on the Eastern Front captured large numbers of SVT-40 rifles. Many German soldiers preferred the captured Soviet semi-automatic rifles to their issued Kar98k rifles. The SVT-40 was not as refined as the M1 Garand. It was heavier, the trigger was worse, the sights were cruder, and it was less reliable in extreme cold or heavy fouling. But it was still a semi-automatic rifle, and that meant faster follow-up shots and higher practical rate of fire compared to a bolt-action weapon. Wehrmacht regulations technically prohibited using enemy weapons as primary armament, but these regulations were routinely ignored on the Eastern Front. German soldiers who acquired SVT-40 rifles often kept them, especially if their units had limited access to German semi-automatic rifles. Some German units officially adopted captured SVT-40 rifles and incorporated them into their TO&E, their table of organization and equipment, particularly in sectors where supply lines were stretched and German weapons were difficult to obtain in sufficient quantities. The German military's official designation for captured SVT-40 rifles was Selbstladegewehr 259, the indicating Russian origin. The Wehrmacht even issued ammunition for captured Soviet rifles through regular supply channels in some sectors. This was a tacit admission that German infantry needed semi-automatic rifles and that captured enemy weapons were filling a capability gap that German industry could not. By late 1944, Germany's strategic situation had deteriorated to the point where equipment shortages affected every aspect of military operations. The Volkssturm, the people's militia organized to defend German territory, was being equipped with a mix of obsolete weapons, captured foreign weapons, and whatever German weapons could be spared from frontline units. Many Volkssturm units received Kar98k rifles that had been rebuilt multiple times, weapons with worn barrels and loose actions that barely functioned. Some Volkssturm units received captured French, Belgian, Czech, or Polish rifles from stockpiles. Some received no rifles at all, only Panzerfaust anti-tank weapons, and were told to rely on those for all combat situations. The Wehrmacht's frontline infantry units were in better shape than the Volkssturm, but still faced shortages. By winter of 1944-45, some Wehrmacht infantry divisions were reporting rifle shortages. Soldiers killed or wounded could not always be replaced with a full equipment set. Rifles were being collected from casualties and redistributed to replacements, but combat losses exceeded the rate at which rifles could be salvaged and redistributed. In this context, the fact that Germany had never successfully fielded a semi-automatic rifle as standard equipment represented a missed opportunity that had compounded over time. If Germany had adopted a reliable semi-automatic rifle design in the late 1930s and had built industrial capacity to produce it in large numbers before the war, German infantry would have entered the conflict with a significant tactical advantage over most opponents. Instead, German infantry entered the war with essentially the same rifle their grandfathers had carried in World War I, a weapon that had been excellent in 1914 but was outmoded by 1944. The Wehrmacht did develop one genuinely revolutionary small arm during World War II, the Sturmgewehr 44, the St. G44, the world's first true assault rifle. The St. G44 was a selective fire weapon chambered for the intermediate 7.92 by 33 mm Kurz cartridge. It could fire semi-automatically or fully automatically. It represented a fundamentally new approach to infantry weapons, bridging the gap between submachine guns and full-power rifles. The St. G44 was developed from the earlier MP43 and MP44 designs, which were essentially the same weapon under different designations. Development began in the early 1940s. The first prototypes were tested in 1942 on the Eastern Front. The design was refined through 1943. Limited production began in 1944. Approximately 425,000 St. G44 rifles were manufactured between 1944 and the end of the war. Like the G43, the St. G44 was never produced in sufficient quantities to become standard equipment. It was issued selectively to specific units, particularly on the Eastern Front, where its combination of firepower and portability was valuable in close-quarters combat. The St. G44 was superior to the M1 Garand in many respects. It had selective fire capability, allowing either semi-automatic or fully automatic fire. It held 30 rounds in a detachable magazine compared to the Garand's 8-round en-bloc clip. The intermediate cartridge produced less recoil than full-power rifle rounds, making automatic fire more controllable. The weapon was revolutionary in concept and would influence infantry rifle design for decades after the war. But the St. G44 arrived too late and in too few numbers to affect the war's outcome. The vast majority of German infantry continued carrying Kar98k rifles through the final battles in Berlin in April and May of 1945. The technological sophistication of weapons like the St. G44 or even the G43 was irrelevant if those weapons could not be produced and distributed in the quantities needed. The United States, by contrast, had achieved the industrial and logistical feat of equipping essentially its entire rifle-armed infantry force with semi-automatic M1 Garands by mid-1943. American industrial capacity made this possible. Springfield Armory and Winchester, Repeating Arms Company, produced approximately 4.5 million M1 Garand rifles between 1937 and 1945. Additional production continued after the war. The M1 Garand remained the standard U.S. military rifle through the Korean War and was not fully replaced until the M14 rifle was adopted in the early 1960s. The contrast was stark. Germany produced approximately 400,000 semi-automatic G43 rifles during the entire war. The United States produced approximately 4.5 million semi-automatic M1 Garands, more than 10 times German production, and the Americans had started earlier, fielded them universally, and maintained consistent supply throughout the war. This production disparity reflected broader differences in industrial capacity and strategic priorities. The United States had the industrial base to mass-produce complex weapons while maintaining quality control. American factories could machine receivers to tight tolerances consistently. American quality control systems ensured that gas systems functioned reliably across millions of rifles. American logistics could distribute replacement parts globally so that damaged rifles could be repaired in theater rather than being written off. Germany never achieved this level of industrial integration for the G43 or St. G44. Production was concentrated in fewer factories. Quality control was inconsistent, particularly as bombing disrupted production and skilled workers were lost to conscription. Logistics struggled to distribute spare parts to frontline units. Many G43 and St. G44 rifles that broke in the field could not be repaired because parts were not available at the unit level. The result was that even the advanced weapons Germany developed often could not be sustained in service. A G43 with a broken extractor became a club if replacement extractors were not available. An S-type G44 with a broken firing pin was useless if firing pins could not be obtained. The Kar98k, by contrast, was so widely produced and so long in service that parts were abundant. Even late in the war, when everything else was in short supply, Kar98k parts could usually be found. This was the ultimate irony revealed by the German evaluation of the M1 Garand at Kummersdorf in November of 1942. German engineers recognized immediately that the American rifle represented superior technology. They documented its advantages. They understood its tactical implications. They knew that German infantry would be at a disadvantage fighting against enemies equipped with semi-automatic rifles, while German soldiers carried bolt-action rifles. But that knowledge changed nothing. Germany could not match American industrial capacity. Germany could not reorganize its economy and manufacturing base to produce millions of semi-automatic rifles while simultaneously fighting a multi-front war against enemies with vastly superior resources. Germany could not even produce enough Kar98k rifles to fully equip all its military formations by late 1944, let alone transition to more complex weapons. The Kummersdorf Evaluation Report, with its clinical documentation of the M1 Garand's 4-to-1 advantage in practical rate of fire, was filed away. The report's conclusions were accurate. The recommendations implicit in those conclusions were impossible to implement. German infantry would continue fighting with bolt-action rifles against enemies with semi-automatic rifles, and the tactical disadvantage would contribute to Germany's defeat in thousands of small unit engagements across Europe. The full implications of the firepower gap between the M1 Garand and the Kar98k became clearer as the war progressed through its final year. Combat reports from every theatre where American and German forces engaged told the same story with slight variations in detail, but consistent conclusions. American infantry could sustain higher volumes of accurate fire, could maintain suppressive fire more effectively, and could fight more flexibly in small unit actions. The Battle of the Bulge in December 1944 and January 1945 provided particularly clear examples. German forces launched a massive surprise offensive through the Ardennes forest, attempting to split Allied armies and capture the port of Antwerp. The initial German attacks achieved tactical surprise and made significant gains. German armoured and infantry formations pushed westward rapidly in the opening days, but as American forces recovered from the initial shock and organised defensive positions, the character of the battle shifted. Small American units found themselves surrounded or cut off, defending road junctions, villages, and key terrain features against larger German forces. In these defensive battles, the M1 Garand's firepower advantage became critical. At Bastogne, the 101st Airborne Division and attached units defended the town against surrounding German forces from December 19th through December 26th. The American defenders, though outnumbered and encircled, maintained defensive perimeters against repeated German attacks. Every American rifleman in those defensive positions carried an M1 Garand. When German infantry advanced across open ground toward American positions, they encountered devastating volumes of semi-automatic rifle fire. German after-action reports from units attacking Bastogne noted that American defensive fire was heavier than expected given the size of the defending force. A report from the 26th Volksgrenadier Division, which attacked Bastogne from the north, specifically mentioned that American positions generated machine gun-like fire, even when German intelligence indicated those positions held only rifle squads, not machine gun positions. The report attributed this to American semi-automatic rifles and recommended that German infantry use more indirect approaches rather than frontal assaults against American rifle positions. The assessment was accurate. American rifle squads at Bastogne could generate sustained fire that sounded like automatic weapons. 8 riflemen with M1 Garands, firing in a disciplined rotation, could keep rounds going downrange almost continuously. The semi-automatic action meant each soldier could fire, acquire a new target, and fire again in seconds without the pauses required to operate a bolt-action rifle. German infantry attacking those positions were still equipped primarily with Kar98k rifles. They had the same disadvantage German infantry had experienced in Normandy, in France, in Holland, and now in Belgium. They could not match American rifle fire volume for volume. Their tactics relied heavily on machine guns for suppressive fire, but American artillery and mortar fire consistently targeted German machine gun positions, forcing German infantry to rely more on their rifles for sustained fire. The rifles could not provide that capability effectively. Individual soldier accounts from the Bulge reinforced this pattern. Private First Class Richard Lockhart, serving with Company F, 2nd Battalion, 503rd Parachute Infantry Regiment, 101st Airborne Division, defending Bastogne, later described engaging German infantry crossing an open field on December 22, 1944. Lockhart stated that he fired approximately 30 rounds from his M1 Garand in less than 2 minutes at German soldiers approximately 150 yards distant. He described the fire from his position, where 6 American paratroopers were firing M1 Garands, as sounding like a firing range with multiple shooters on the line. The volume of fire forced the attacking Germans to go to ground, breaking up their assault before they reached the American position. Lockhart specifically contrasted this with his experience fighting German forces in Normandy, where he had observed captured German Kar98k rifles and noted how slow the bolt action was compared to his M1 Garand. He stated that he would not trade his Garand for any other rifle, including captured German weapons, because the semi-automatic action gave him confidence that he could engage multiple targets quickly if needed. Similar accounts appeared throughout American veterans' memoirs and oral histories. Soldiers consistently mentioned the M1 Garand as a reliable, effective weapon that gave them confidence in combat. The rifle became closely associated with American infantry effectiveness. Its distinctive ping when the en-bloc clip ejected became one of the characteristic sounds of American infantry combat, recognized by soldiers on both sides. General George S. Patton, commanding the U.S. Third Army in Europe, was famously enthusiastic about the M1 Garand. Patton had observed American infantry in combat extensively throughout the North African, Sicilian, and European campaigns. He understood infantry tactics and the importance of individual weapons. In a speech given after the war, Patton made a statement that would become one of the most famous assessments of the M1 Garand. In my opinion, the M1 rifle is the greatest battle implement ever devised. This was not hyperbole from a general trying to boost morale. Patton's assessment was based on observing how American infantry performed in combat with the M1 Garand as their standard weapon. He had seen American rifle companies engage German forces repeatedly. He understood that American infantry could generate firepower levels that exceeded what equivalent German units could produce. He attributed this directly to the M1 Garand's semi-automatic operation. Patton's comment reflected a broader recognition within the U.S. military that the decision to adopt the M1 Garand as standard equipment had been strategically significant. The rifle had given American infantry a tactical advantage that contributed to battlefield success in measurable ways. American infantry could attack more aggressively because they had confidence in their ability to deliver sustained fire during assaults. American infantry could defend more effectively because they could generate higher volumes of fire from defensive positions. The weapon enhanced infantry effectiveness across the full spectrum of combat operations. The German military never achieved this level of universal confidence in any of their infantry rifles during World War II. The Kar98k was respected as reliable and accurate, but soldiers understood its limitations. The G43 was appreciated by those who received it, but its limited availability meant most soldiers never had the opportunity to use one. The St. G44 was revolutionary, but too few were produced to create widespread impact. German infantry ended the war knowing their standard rifle was inferior to American standard rifles, and that knowledge affected morale and tactical confidence. After Germany surrendered in May of 1945, American and British forces conducted extensive evaluations of captured German weapons and equipment. Intelligence teams examined German small arms development programs, interviewed German ordnance engineers, and reviewed German military assessments of Allied weapons. The reports from these post-war evaluations provided additional context for understanding how German military leadership had viewed the M1 Garand. A. U.S. Army Ordnance Department Technical Intelligence Report published in 1946 compiled information from interrogations of German ordnance engineers and Wehrmacht officers. The section on infantry rifles included statements from multiple German sources, acknowledging that the M1 Garand had provided American infantry with significant tactical advantages. One German ordnance engineer, whose name was redacted in the published report, stated that German military leadership had recognized since 1943 that American infantry were equipped with superior individual weapons, but that Germany lacked the industrial capacity to respond effectively. Another German officer, a battalion commander who had fought American forces in both Italy and France, stated that his soldiers had quickly learned to respect American rifle fire because of its volume and consistency. He noted that German infantry tactics had to be adjusted to account for American firepower advantages, particularly in close-quarters combat, where the rate of fire differential was most pronounced. The post-war intelligence reports also documented the extent of German semi-automatic rifle development programs. The reports showed that Germany had invested significant engineering effort in developing weapons like the G41, G43, and staged G44. German ordnance engineers understood the tactical value of semi-automatic and automatic weapons. They had created designs that were, in some respects, more advanced than the M1 Garand. The St. G44, particularly, represented a conceptual leap beyond the Garand, introducing the intermediate cartridge and selective fire capability that would define infantry rifles for the next 50 years. But advanced designs were meaningless without production capacity and logistical support. The United States had both. Germany had neither in sufficient quantities. American industry produced M1 Garands in the millions, distributed them globally, maintained supply chains for ammunition and spare parts, trained soldiers to use them effectively, and sustained those systems throughout the war. German industry produced advanced rifles in the hundreds of thousands, struggled to distribute them beyond frontline units, could not maintain consistent parts supply, and watched as the weapon's tactical potential went unrealized because too few existed to make strategic difference. The story of the M1 Garand evaluation at Kummersdorf in November 1942 ultimately illustrates a fundamental truth about military technology in modern war. Superior engineering must be matched with superior production and logistics to create decisive advantage. German engineers correctly identified the M1 Garand's capabilities. They accurately measured its performance. They understood its tactical implications. They wrote detailed reports documenting all of this. None of it mattered because Germany could not respond effectively. The Wehrmacht fought World War II with an infantry rifle designed in the 19th century, while their primary opponent fielded a rifle representing mid-20th century technology. That technological gap, measured precisely in the Kummersdorf tests as a 4-to-1 advantage in practical rate of fire, translated into tactical advantages in thousands of small unit engagements across Europe. Each individual engagement might be minor, but the cumulative effect was significant. American infantry could fight more effectively because they had better tools. The German ordnance engineers who tested the M1 Garand in November 1942 knew exactly what they had discovered. They documented it carefully. They reported it accurately. The reports were read, filed, and ultimately set aside because the conclusions, however valid, pointed towards solutions that Germany could not implement. The engineers had identified a problem Germany could not solve. By the time the war ended, American industry had produced approximately 5.4 million M1 Garand rifles. Production continued after the war. The rifle remained in American military service through the 1960s, seeing combat in Korea and the early years of Vietnam before being replaced by the M14 and later the M16. The M1 Garand service life spanned nearly 30 years as a frontline weapon, a remarkable achievement for any military rifle design. German semi-automatic rifles, by contrast, disappeared rapidly after the war. The G43 remained in limited use with some Soviet and Eastern European forces who had captured them, but production ceased permanently with Germany's surrender. The Sant G44 influenced subsequent rifle designs. Globally, the Soviet AK-47 showed clear conceptual similarities to the SAT G44's intermediate cartridge and selective fire approach, but the weapon itself passed into history. The Kar98k had a longer post-war life. Ironically, millions of Kar98k rifles remained in stockpiles after the war. Various nations used them for decades. Yugoslavia manufactured Kar98k rifles under license into the 1950s. The rifle remained in service with some military and police forces into the 21st century, not because it was superior technology, but because it was simple, reliable, and available in enormous quantities. The weapon that had handicapped German infantry during World War II continued serving simply because it worked and parts were plentiful. The contrast between the M1 Garand's tactical superiority and continued service versus the Kar98k's obsolescence and persistent availability illustrates the disconnect between engineering excellence and strategic success. The best weapon is not necessarily the most advanced weapon. The best weapon is the weapon that can be produced in sufficient quantities, distributed effectively, maintained reliably, and employed successfully by the soldiers who carry it. The M1 Garand succeeded on all those measures. German semi-automatic rifles succeeded on some measures, but failed on others. The Kar98k succeeded on production and maintenance, but failed on tactical performance. When German engineers opened that crate at Kummersdorf on November 7, 1942, and examined the M1 Garand inside, they were looking at the weapon that would help defeat them. They tested it thoroughly. They documented its capabilities accurately. They understood what it meant for German infantry facing American forces equipped with that rifle. But understanding the problem was not the same as solving it. Germany never fielded a rifle that matched the M1 Garand's combination of performance, reliability, and availability. German infantry fought the entire war at a firepower disadvantage against American forces. That disadvantage, measured precisely in the firing tests at Kummersdorf as 40 rounds fired from an M1 Garand in the time required to fire 10 rounds from a Kar98k, accumulated across millions of infantry encounters into a pattern of tactical defeats. Each defeat was small, each was survivable, but the pattern was inexorable. American infantry could shoot faster, and in infantry combat, speed often decided outcomes. The German engineers who conducted the Kummersdorf evaluation understood this. Their reports said so explicitly. But their recommendations, however technically sound, required resources and industrial capacity that Germany did not possess. The evaluation reports documented a problem that could be recognized but not resolved, and so German infantry continued fighting with bolt-action rifles while their enemies carried semi-automatic weapons, and the predictable consequences unfolded on battlefields across Europe until Germany's final surrender in May of 1945. The M1 Garand did not win World War II by itself. No single weapon system determines the outcome of conflicts as complex as global war. But the M1 Garand gave American infantry a consistent tactical advantage that contributed to victory in measurable ways. It allowed American soldiers to fight more effectively. It provided confidence that their weapons were as good as or better than enemy weapons. It demonstrated that American industry could produce advanced equipment in the quantities necessary to equip entire armies. The rifle that German engineers tested at Kummersdorf in November 1942 proved to be exactly what their evaluation predicted: a superior infantry weapon that would give American forces significant tactical advantages throughout the war. The engineers were correct in their assessment. Their reports were accurate. But accuracy could not change the fundamental reality that Germany had entered a war against enemies with superior industrial capacity, and that industrial capacity translated directly into better equipment for frontline soldiers. That was the lesson German ordnance engineers learned from testing the M1 Garand. It was a lesson learned too late to matter. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.